All right. Let's be looking at this bell work here. I've heard a couple people mention it, but our axis of symmetry, what we're looking at here, we talked about this yesterday. That's our x equals the opposite of b over 2a. Got a and not b2. There we go. So they look like different things because my a's and my 2's are too creepily similar. So looking at equation A, this guy, how do I put this together? X equals negative 18 over 2 times 1. So where's our axis of symmetry? At negative 9. Thank you. So we simplify it, and that gets us to negative 9. So if I was asking you to graph this one, we would start with our minus 9 in the middle on our table. What about for equation B? How are we going to build this one?
Negative
2 times 2, because it's this 2 here. So this becomes kind of gross. Negative 9 over 4. Yeah, or negative 2 1/4. Ew. Doable, but ew. And then what about this one? C.
12 over 2 times 3.
Mm-hmm. Since this is a negative 12 here, we put the opposite of negative 12, which you can put it as our double negative first, or if we can spot that that's going to be a positive, you can absolutely do that. Over 2 times our A, and our A here is 3. What does this simplify down to be? 2. Because the 2 times 3 gives me 6. 12 over 6 is 2. Okay. Questions on that bit? What's up? It's always 2 times our A. So it's the number in front of the x squared. So on this one, this was 2 times 1. This one was this 2. And this one, it was this 3. So it's always the number in front of the x squared. Good question. Good question. I don't know what we're not sure of unless we actually asked a question. So I just need somebody to be brave and ask it. Good question, because I heard a lot of people go, oh, on that one. Okay. Any more questions? Cool. Because we're going to work a little bit more with some graphing. But we're not going to be using our standard form like this. Today we're going to go into something called our vertex form, which is going to look incredibly familiar.
Let me guess, we've done it before.
It looks just like the absolute value stuff. Oh my gosh. So I have this image for you guys so you don't have to try and speed write this down. Again, you don't have to use these things if that's up to you guys, but it's one of those favorite things.
Can we do this in kind of look at the corner?
If you want to. I recommend it, but you know, I'm not going to. But it's one of those things that it's handy to have a resource to look back at when we're working on things like homework. It's nice to have a quick, easy, I can find everything I need to on this page. So we've seen these pieces before inside this type of equation. We have A and H and K, which we used back in chapter 1 when we were graphing our absolute values, when we were doing the transformations. This is called transformation form or called vertex form. And they have the exact same jobs they had before. They follow the exact same rules they did before. And so we're going to go through them real quick just to remember what they are. So this is called the refresher on transformations. This is also regarding vertex form, is what this is also called. So I'm going to start with H because its box is on the top. H is always inside the parentheses. Our formula has a minus sign, so it is always, 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 always the opposite sign of what we see in that expression. So it's always the opposite sign of what you see in the expression. And the expression I mean is the this guy. That's the expression I'm talking about. It always is going to have the opposite sign of that expression. And if H has a positive value, if H is greater than 0, which way is it going to go? If my H is 3, positive 3, my turn to talk. If my H is positive 3, which way would it shift? Positive 3. Which way do positive numbers go? Not the expression of plus 3. H equals positive 3. What if I had an equation of, I'm just going to go with x minus 3 squared. So my H is positive 3. Which direction would that go? What does H do? H is our hula. Horizontal. So which way would a positive 3 go? To the right. Just like on our number line at the top of the board. Positive numbers go to the right. I'm shifting to the right 3. So if my H is greater than 0, it's going to go right. So then let's talk K, just because we're going to move the top down. K is tucked onto the end. It's the sign we expect it to be. So there's nothing weird about the sign in there. So if K is greater than 0, we want to know which way it shifts. Which way does K move us in general? What kind of transformation is K? Up and down. K's our vertical. So I'll just draw it here. So this one's our vertical. Up and down. H does our horizontal. So if K is positive, if K is greater than 0, which way is that going to move us? Up. If K is less than 0, which way does that move us? Down. So K doesn't have a whole lot of trick to it. H, we have to be really careful because of that opposite sign. But K is not super duper tricky. Which makes up for A because A has too many dang jobs. A's got a lot of stuff going on. So A, our guy multiplied out in front. So if A is negative, so if I have a negative number out front, what does that do? Do you remember? That's when it flips upside down. It takes it and reflects it across our x-axis. So if A is negative, it reflects across the x-axis. And again, we're going to practice being specific. It's not going to come up this, oh, it might come up this semester. It's not going to come up this chapter, but it will come up later in the year. to have other kinds of reflections, but it's not super common. But we're just going to be in the habit of being specific. So that just deals with positive versus negative. Positive, it's right side up. Negative, it's upside down. So then we also need to look at the value of A. If the number, the absolute value of A is greater than 1, so I have a bigger number like 2 or negative 2 or 12 or negative 12. Remember what a transformation that does? What is that called? If I have a big number. It's a stretch. That's when we're a big kid, we do our big kid yoga. And it gets up really, really tall and really, really skinny. So it took like our absolute values and it made them go and gets them really, really tall. So if we have big numbers, that's when we do our big kid yoga, and it is a stretch. This is a vertical stretch. If you just say stretch, I'm okay with that. We're not going to do any other kind of it. Makes my brain itch if I don't. We're not going to introduce any other kinds of stretch. And then if we have little bitty numbers, 1/2, 1/4, negative 1/2, negative 1/4, what is that called if they're little bitty? They're compressed because they're just so little and cute. I want to squish them. I want to squeeze you. So that is when they are compressed. And I'm going to say vertically compressed. And yes, I know that sometimes I am ridiculous. I promise it helps y'all remember. Because it's so little and cute. It just wants to squish it. Squish. Okay, so all of these pieces have the same exact jobs they had the last time we looked at them. Back in Unit 1, we used them. I use them in Unit 2 a little bit, but not tons. But we used them a lot in Unit 1 when we were doing absolute values. So they have those exact same jobs. So what we're going to start with is we're going to start with identifying our transformations. But there's one thing we really didn't talk about when we looked at these in Unit 1, because it was very specific to parabolas and x squareds, is the fact that this is also called vertex form. The reason this is called vertex form is because inside this equation is written my vertex. So we're going to have, and you're going to want to write this piece down, a vertex located, so that very bottom, our absolute minimum or our absolute maximum, the tippy tippy top or the tippy tippy bottom, is located at the point H, comma, K. Every single time. If we are in vertex form, I can find my vertex with no calculation needed. So I won't even have to use axis of symmetry to find it. It's H. Every time. Every single time. So what we're going to start with is I'm going to give us some equations. We're going to find our transformations. And we're going to find our vertex. And that's how we're going to start. Finding those pieces. And then we'll practice how we graph those. That is not the one I wanted. That one. Yeah, I can rest. All right, so we're going to identify our transformations and our vertex. Hey, Alex. All right. So we're going to find our A, our H, and our K. We'll say what those mean, and we're going to write down our vertex. So I'm going to write our kind of basic form up here, our Y equals A, X, minus h squared plus k. So that's kind of our basic form. So on this first equation over here, what is our a? -1. It's this guy out in front right here. There's a highlighter. That guy right there is my a. What does that do as a transformation? What does a negative a do? It reflects. That's when we reflect across the x-axis. Makes the whole thing upside down. I forgot the O in the word across. Spelling is a suggestion, y'all. Close enough for Google, it's close enough for me. All right, then let's look at our H. What is our H gonna be? Careful, careful, careful. -7. It always has the opposite sign to this expression. So since that says x plus 7, H actually is -7. It has the other sign. So since it had a plus, this one has a minus. So which way is that shifting it? Which way does an H of -7 go? Left. Yep, H, that's our horizontal. So this is going to go left. 7. That's that guy. And then what about our K? Yeah, our K is -3. It's this guy on the end over here. That's not the highlighter. That guy. There we go. So K is always just tucked on the end. So this is going to go down 3. So then we're going to write in a piece we don't usually do, but we didn't do before. We're going to write our vertex as a point. So our vertex is every single time going to be at h comma k. So our vertex is going to be at the point -7 comma -3. Questions on any of those pieces? We're going to do the same for the other two, but we'll go a little bit faster on the other two. Okay. Then let's do the same thing over here. What is our A? 2. What does that mean transfer relations-wise is happening? It's a stretch. What is our H? -3. Good. It always has the opposite sign of this expression in here. So it's going to be -3, which means which way is it going? Left. And then what's our K? 4. And it's going to go up 4. So where's our vertex? -3, 4. H comma K. Every single time. And let's do our last one like this, and then we'll go see how this helps us with graphing stuff. What's our A on this one? 1/4, which means what's happening transformations-wise? That's compressed. It's just so little and cute. I want to squish it. This is compressed. On our graph, when we look at it, it looks like somebody sat on it. So it goes, like somebody squished it. What's up? Not necessarily, because I could have an A value of 2.5. That's still bigger than 1, so it'd still be a stretch, even though it then still is a decimal. But if it's between 0 and 1, that will be compressed every single time.
Isn't 2.5 just 1/4 and decimal 1?
0.25 is 1/4. 2.5 would be 2.5.
So
Anything above 1. Anything above 1 is a stretch. Anything below 1 is a compress. Negative makes it reflect. So, like, that's only looking at positive values.
It's almost like
Not like they mean it. Yeah, not like you mean it, dude. All right, what's our H on this one? 10, positive 10. So which way is it going? Going right. What's our K? 13, so it's going up. And where's our vertex? 10, 13. H, comma, K. Okay, so we're going to use this to help us do a little bit of graphing. Oh my God, the says it's great. We're probably only going to get to 2. I only get to 1, but we'll see. So I'm going to pass them out, but if you don't use all, we might not use all of them. We probably won't use all of them, but. It's way easier for y'all to cut 2 than for me to cut 75. So we're probably not going to use all 3. Any extras you have, we can just leave on the table because I use them 3 more times a day. So. But some graphs are better than none graphs. And too many graphs are better than none graphs. The graphs will be. So, but we're going to use what we just did to help us with the graphing part.
Are we going to use graphs tomorrow?
Tomorrow we are. I can't remember. Yes.
Okay. Because I'm just going to.
That's fine. Yeah. Yeah, we're going to use graphs a little bit tomorrow too. We're going to start with this one. And we have a couple of different ways we can approach this. You can do this exactly the same way we did absolute values, where we make a parent function in the middle and we do our x plus h to one side and our y a plus k to the other side. That is 100% a valid way to do it. You don't have to do it that way though. And we're starting to kind of shift away from that a little bit, I guess. So where we're going to start is we're going to figure out where we want our middle to be. Which means I want to figure out my vertex. X and Y. Oh, my disky disc is broken. Okay, so in order to do that, I need to know where my vertex is, which means I want to know where my H is and where my K is. So what is H? 2. And it always has the opposite sign, so it's a positive 2. What is my K? -4. So my vertex is at what point? 2, -4. Well, that's going to be the middle on my table. That's where we're going to start. So we're going to put our vertex here in the middle. So we're going to have 2, -4. So we know our first point's right here. That's my vertex, which means my axis of symmetry is right there as well. So if we need our axis of symmetry, it goes through our H. That is, you can spell axis of symmetry wrong without even writing the word symmetry. Love that. Our axis of symmetry is always going to happen at our x equals h. And so all that means is as long as I put my 2 in the middle for this one, I know it's going to reflect on either side. So I have half the values we need to calculate. So we want to have some x values that are bigger, some x values that are smaller. And we're going to count outwards from there. So I do recommend going by ones. So some things smaller than 2 would be things like 1 and 0. Things bigger than 2 would be things like 3 and 4. And to get our y values, we're going to substitute them in. But since I know that I've got my vertex in the middle here, these pieces are going to match up. So we do not have to calculate near so many as we did before. So if we take and substitute in 1 into our equation, 1 minus 2 as a quantity squared minus 4, and you can type it into the calculator exactly like that. We can do parentheses 1 minus 2 parentheses square minus 4. And you can type it in exactly like that. Excuse me. Hiccup herb. I hate those. Those hurt so bad. What do we get when we do that?
-3.
-3. So we know that when x is 1, this is -3. And since I know that this guy's my vertex, I know that this guy is also -3. Do the same thing for the last value, which my screen didn't jerk. There we go. For either 0 or 4, they should have the same value because we've got that axis of symmetry in the middle. We are in vertex form, not in standard form, so we can't just use the c value for our y-intercepts. We do have to actually calculate something. So do the same thing with either the 0 or the 4. Our y equals 0 minus 2 squared minus 4, or 4 minus 2 squared minus 4. Either way, what do we get for our y value? 0. And this one's also going to be 0. Because we have that axis of symmetry in the middle, we know that's going to be 0. So then what we get to do is we get to plot up our points. We have a point at 0, 0. We have a point at -1, -3. Or sorry, +1, -3. 2, -4, 3, -3, and 4, 0. Ooh, that was trash. Let's try that again. Then we're going to connect them up and make it pretty much U-shaped, but also no. It's really hard to get right. They look kind of like that. So not too bad. Not too bad. We've had worse kinds of graphs before. It's a lot of put it in the calculator to get values. And then we just have to know how to plot the points. But it's less calculatory than doing it with the parent table, x plus h, y plus k. So what is our domain of this function here? Positive infinity and negative infinity. But we're always going to do it from smallest to biggest, so I'm going to go negative infinity to positive infinity. That is how far left, how far right. Range, that's the other direction. How far down, how far up. So how are we going to write our range on this one? -4 is our very lowest. 2, our very biggest, is as big as you could possibly imagine. So we put infinity. Yep.
And the square bracket and the -4 is given to touch it.
Because I can touch it. It's right there. I always think of the square brackets as like that annoying little sibling. That was me. 9% that was me. Okay, questions on this one? We're going to do another one very much like it, but I just wanted us to kind of see it the first time. All right. Let's do another one. So first things first, what are the transformations going to be on this one? I've got a lot of 3's in here. What should we expect to happen? Say it louder. We'll probably see some decimals. Why are we going to see decimals? Because 3 likes being decimals. Not wrong. But we've got this fraction out here, right? So we may have decimaliness. And that's okay. We can deal with it. What are the transformations we're going to see here? What does our A tell us? It's going to be compressed and reflected. So it's going to go and squish like somebody sat on it, and it's going to flip upside down. So the reason we think about our transformations like this is so we can use it to kind of spot check that things go right. I expect this to be upside down and kind of short. Which way should it shift? What's our H going to be? Negative 3, which means which way does it go? Left. So we expect it to go left. How about our K? Negative 3, so we expect it to go down. So we should have a short, wide, left, down parabola. So where's our vertex going to be? Negative 3, negative 3. So when we're in our table, we're going to put negative 3 in the middle. Negative 3, negative 3. This should be our vertex right here. So to find our other points, we're going to take some that are smaller than negative 3, like negative 4 and negative 5. And we're going to take some bigger than negative 3, like negative 2 and negative 1. And we're going to substitute those into our equation. And you can do that exactly as it is right there on the calculator. Just typing it in exactly as you see it. That second column, third button down, is my favorite button in the whole wide world. That is our fraction button that looks like a fraction. And so you can take our negative 1/3 and do our, let's say, negative 5. There we go. So our fraction button is the second column, third button down. It looks like a fraction. And we're going to do our negative 1/3 times our, I'm going to go with the negative 5 plus 3. Close it. Use the square. Minus 3. It looks just like the equation we have on our paper. And it gives me negative 13/3, which is great, but not super helpful when it comes to graphing. So we're going to hit the 2 little arrows right above it, and we have negative 4.3-ish. So, negative 4.3. Give yourself 1 decimal place, because when we're graphing, there's a difference between being right at negative 4 or being at negative 4.3, so a little bit below 4. So give yourself a decimal place, but you don't need to have like a gazillion of them. So do the same thing with some other points. Since we put our vertex right in the middle, I know that this guy is also going to have a value at negative 4.3. So we really only need to type in one more. So substitute in either the negative 4 or the negative 2. They should have the same value. What do you get? Type it in. Type in, like, say, the negative 4 into that same equation. negative 1/3. Negative 4 plus 3. You can type it in just like this. What do you get? Negative 3.3. So it gives me negative 10/3, which I go, great, that's super helpful. Not. Hit the 2 arrows that are right above the enter key, we get our negative 3.3. So negative 3.3, which because my vertex is right in the middle, I know that this guy is also negative 3.3. So then we can plot up our points between negative 3 and negative 4 on my y-axis and negative 4 to the left. My negative 2 is between negative 3 and negative 4. And when x is negative 1, my y is between negative 4 and negative 5. And so we can see here that we do in fact have an upside down, kind of squished, shifted left, and shifted down parabola. What's up?
So, like, what is this 4.3? Why does it go down to the other end? Like, what indicates that it can go?
Since we put our vertex in the middle, since this guy is the middle, I know that this is where my axis of symmetry is. So if I look at my graph, that line, I can fold it in half, goes right here. As long as we put that vertex in the middle and we count out by ones, they will line up. So unless you go a little rogue and start going like with negative 3 in the middle and do negative 5 and then negative 10. And then we do 2 and 1 on the other side. Like, don't go rogue with your counting. Just count by ones and don't make it hard on yourself. Because then we can match it up and it is half of the things we need to type in. It's like you absolutely can pick whatever values you want. Some of them are going to be off the graph if you get too far away from your vertex. Okay? Last question. What's our domain? How far left? How far right? Negative infinity, positive infinity. What's our range? Negative infinity. Good, that's our lowest point. To negative 3. Okay? You guys can now do everything on homework 1. 3.1. Yep, I'll put it back on here very briefly, but then I have to pull up announcements.